So now we're going to get into the most important technique that you learn in your first semester calculus or AP, calculus AB, is the U-substitution. So the U-substitution is a technique to sort of is to do integrals of other forms like this. So for example, say I wanted to do the antiderivative of this. And you might think, oh, well, I just do the antiderivative of each of these separately, right? And then I'll just do times the power rule. So 1/8 x cubed minus 5 to the 8th, right? But you might realize, like, oh, wait, if I take the derivative of this, it's like I got to do product rule, because the derivative of this is definitely not going to be this thing. So then I got to do product rule. So then I got to, like, divide things. Or this one I got to do chain rule. So then do I divide by 3x squared? But then I have a problem by dividing this, because now if I take the derivative of this, I'm supposed to do quotient rule, right? And so you get in this kind of nasty web that I cannot simply just divide out things with x or multiply things with x to sort of undo the product or quotient rule. So that's not really the approach you can take. The U-substitution is to reverse chain rule operations, okay? And so I'll kind of do it as an example here. So in this case, what we're going to do is, my goal is to convert this into an integral of a known form that I can do. And the known forms are the exponentials, or power rule, or trigonometry, or inverse, or tangent, in any of the inverse trig functions. It's like some basic forms that I know, but if it's not in that form, I can't just simply do the antiderivative. So here, I'm going to say u is equal to x cubed minus 5. And we're going to use differentials. Kind of, if you remember from our differential stuff, we're going to use du is equal to 3x squared dx. That would be the differential for this. Okay? And the whole goal is to say, like, well, I'm going to try to replace all of the x's with some form of u in it. So, for example, my 3x squared dx, I can replace with du. And this part, I can replace as u to the 7th. So this is really integral of u to the 7th du. This is why we call it substitution. I have replaced every part of the x's with u's. And you see, note that now, this I can just do power rule. 1/8 u to the 8th plus c. The last step we do here is resubstitute x, because I want my answer in terms of x. And I want 1/8 x cubed minus 5 plus c. Or to the 8th power plus c. This would be my answer. And note, if I were to take the derivative of this, I would get this. If I were to take the derivative, I would do 1/8 times 8 x cubed minus 5 to the 7th. And then because the inside's not x, I take the derivative of the inside, the 3x squared. These 8's cancel. And you see, I'm left with exactly what I started with. So that's the idea of the U-substitution that we're going to do. Okay. So in every problem, the U-substitution is typically pretty easy to spot in a lot of problems, but sometimes they can get a little bit tricky. And so we're going to go through each of these. And there's sometimes you might have to try the U-substitution a few different ways to find the right answer. So in this case, I'm going to say u is equal to x squared plus 1, because I'm kind of thinking this part, I want to make this u to the 8th. And I'll note that du, the differential, would be 2x dx. Now I don't have a 2x dx over here. I only have an x dx. So I gotta compensate it by dividing by 2 to get an x dx. And now I can replace this part with 1/2 du. So this would be the 1/2 du times u to the 8th, which is really, if I rearrange the terms, 1/2 the integral u to the 8th du. And so that's 1/2 1/9 u to the 9th plus c. And so that's 1/18. And then u to the 9th I replace, because I want my answer in terms of x squared plus 1 to the 9th plus c. Okay. Here I'm going to say u is the denominator. U is equal to 2x plus 7. I'll show you what happens. Du would be 2 dx. I don't have a 2 dx. I have simply a dx over here. So this dx I replace with 1/2 du. So this becomes the integral of 1 over u times 1/2 du. Or if I bring the constant in front, it's 1/2 integral 1 over u du. This one is not power rule. This is a special run, because du over u, or 1 over u, the antiderivative of that is natural log absolute value of u plus c. Now, the absolute value is technically necessary, and I would be precise in making sure you always leave that in there, unless you know for a fact that u is positive or negative. You can remove the absolute value signs. Okay, here is one like this. The tricky part here is the square root, so I'm inclined to make u is equal to x plus 3. And you might think, you might try u equals square root of x plus 3 first. Like, this would be a common thing to do when you're learning, when you're first starting out. But if you think about the differential, I'm going to have a 1/2 x plus 3 to the negative 1/2 dx. And I guess you could kind of do it, but then I'm left with an x up here. It's a little tough to deal with. So I'm going to do with the substitution is a little tricky. Is all I'm saying here. You can do it this way. But I like u equals x plus 3 a little bit better, because I would say du is equal to dx. And then you might say, like, okay, well, what about this x? So I'm going to have this integral of x du, because I can replace the dx with du, and I can divide this by square root of u. And this is a good question. What am I going to do with this x? I have to look back at this expression and be like, can I solve for x? Well, I can make u minus 3 equal to x, right? And so then I could replace this with the integral of u minus 3 over the square root of u du. Now you might think, well, that's not necessarily any better, but now I can do some algebra to split this. And if I think about u over square root of u, that's square root of u. And then I can put these into power rules. And so then I would get u to the 3/2. I add 1 to the exponent. I divide by that exponent. Minus 3u to the 1/2. Add 1 to the exponent. Divide by that exponent. Plus c. And then replace the u. So I flip these fractions to the numerator, and I replace the u with x plus 3. And so I'm going to get 2/3 x plus 3 to the 3/2 minus 6 x plus 3 to the 1/2 plus c. And I would just leave my answer like that. Okay. Here, my u is going to be square root of x, because the only the trick, the way I would identify this is say, like, well, the exponential, the only thing I can do is e to the u. That's the only form with exponent that I know how to do, so I should have it like this. Du would be 1 over 2 root x dx. And you see this 1 over this dx over x I have right here. So 1/2 du is going to equal to this 1 over root x dx. This part right here. So I can replace this as the integral of e to the u times du. And we know that's simply e to the u plus c. And replacing u with root x, that's e to the root x plus c. Okay. Thanks for watching. If you're looking for more examples, go to my website. In there, I have free access to over 400 calculus questions that I solve and I show you step by step. So if you're interested in seeing more, please check out my website.